Okay, let me now introduce Rolle's theorem. Okay. So let f be a function that satisfies the following three properties. Okay, so the first property is that it is continuous on the closed interval AB. Second is that f is differentiable on open interval AB. And the third is that f of A is equal to f of B. Okay, so let's say these are the three conditions that the function satisfies. Okay, then Rolle's theorem says that there exists a number C. Okay, then there is a number C in the interval AB such that f prime C is 0. Okay, now let me just explain this to you in picture. Okay, it's not that difficult at all, you know, it's very easy to understand. So what are the conditions of the Rolle's theorem? Well, function should be continuous on this interval. So obviously, you know, when I'm going to draw the graph, I will not I do not have to lift my pen. Okay, and the other thing is that f is differentiable on AB. So basically that means when I draw the graph, I also avoid, you know, kinks in the graph. So it has to be smooth, you know, whatever it is, it has to be smooth on this interval. Okay, and then I also assume that f of A is f of B. So what that means is function takes the same value at A and B. So the function must pass through these 2 points. Okay, so if I keep this constraint in mind, all these 3 constraints in mind, and if I try and draw the graph of some function, okay, so one possibility is that, let's say if I decide to go up in this direction, okay, basically the function is going up here, okay, then do you agree that I have to come back here? So if I have to come back here, then at some stage I'll have to come down. Okay, so if I have to come down at some stage, this is the stage where f prime c is 0. So there is a number c such that f prime c is 0. So if the function decides to go up here, then you know, at some stage it will turn back because it has to go there. Okay, so it's possible that it might go down and then come back, but the key thing is, you know, it has to, if it goes up then it must come down, and if it does that, then at the point where it does that, the derivative will be 0. Okay, so basically there'll be some c here where f prime c is 0. Okay, so that's one possibility. Okay, the other possibility could be that, you know, the function is going down, okay, here. Okay, so do you agree if the function goes down here, then it has to come up to actually reach this point? Okay, so again you can see that, you know, whenever it does that, there'll be a point where f prime c is 0. Is that okay? Okay, so these are the 2 cases, and another case is it goes straight like this. Well, if it goes straight like this, then everywhere you will see that f prime c is 0. So there is a number c in between A and B such that f prime c is 0. So basically, no matter what happens, whether the function goes up from here or down from here or goes like this, you will find some point where f prime c is 0. Is that clear to everyone? That's exactly what Rolle's theorem is. Okay, so another way of saying the same thing is that the tangent to this graph becomes parallel to this line at some point. Okay, I mean, that's how you can interpret f prime c, right? I mean, f prime c is basically the slope of the tangent. Okay, so the tangent becomes parallel to this particular line at some point. Okay, that is what Rolle's theorem says.